A concentrated vertical load of 3000 kilonewton is applied on a horizontal ground surface. Points P and Q are at depths 1 meter and 2 meter below the ground respectively along the line of application of the load. Considering ground to be a linear elastic isotropic semi-infinite medium, the ratio of the increase in vertical stress at P to the increase in vertical stress at Q is what? So let's read it again. Just a concentrated vertical load of 3000, let us denote it by Q, is applied on a horizontal ground surface. So let us take a surface, okay, this is ground level. Let us say there is a load which is applied which is equal to 3000 kilonewton. So it's a point load because it is concentrated vertical load, and points P and Q are at depths 1 meter and 2 meters below the ground respectively along the line of application of the load. See, along the line of the application of load. So exactly below this load there are 2 points which are at a distance of 1 meter and 2 meter below the surface. Let us take this is P, let us take this is Q, whereas this is 1 meter and this is also 1 meter because total depth is 2 meter, right? So 1 meter, 2 meter. Now what is asked? Considering the ground to be linear elastic, isotropic, semi-infinite medium, the ratio of increase in vertical stress at P. So increase in, let us change the color, okay. So increase in vertical stress. So there is a formula. If you see, while reading the question itself, you should understand what is the formula which should be used, because they have given some particular assumptions coming to the ground. So these assumptions and this concentrated means point load, taking all these things, so Bosin's theory or Bosin's formula you should use for it. What is that formula? It's increasing effective stress can be given by 3 by 2 pi into 1 by 1 plus r by z square whole power into q by z square, right? So now here we will know what is r, what is z, what is q, what is z. So this is delta sigma, which is increase in the stress. Now let us take three-dimensional ground surface, okay. There is a application of the load here, Q, okay. So this is the line of application of the load. You are taking a point randomly somewhere, let us say at this point, okay. This is P. You want to know the stress change, increase in the stress at this point due to the Q. What do? So that if you draw a vertical line to the ground surface, okay, this is P dash, let us say, on the ground surface, okay. So the distance between these two is R. The minimum distance between the two lines, what is that? One is the line of the application of the load, another one is the line of the the vertical line in which the point is existing. So anywhere the minimum distance, you can't take distance between this ground surface to the point where you want to. This is not the R, this is R, okay, the minimum distance, horizontal distance, remember. And what is this? This is the distance between the ground surface and the point, vertical distance. This is Z, right? If you know these two values, R and Z, you can substitute in this formula. And what is Q? Q is the load which is applied. You know Z, you know R, you know Q. Then you can find out what is the increment in the stress at that point. Okay. So what are the given points? Sigma, delta sigma P, delta sigma Q, which we need to find out. Okay, delta sigma P and delta sigma Q. Okay, what is asked? The ratio of the increase in the vertical stress at P. Okay, sigma at P to sigma at Q. This is what the question. Okay, now I'll write formula 3 pi 2 by 2 pi 3 by 2 pi 1 plus 1 r z square whole power into Q by z square. See here the P and Q are existing exactly below, right? Somewhere here and somewhere here, P and Q. Let's take P1, so PG1. Okay. In the question, so R value is 0. If R value is 0, this total term will become 1. So you will be left with 3Q by 2 pi z square. Okay. So what is, let us keep 3 as 3, 2 pi, Q as Q. Okay, because Q is same, only Z is different from P to Q. So what is the P here? Z is 1 square. So what is here? Also Q is exactly under this point of application of the load. Then it will also become 1. Then again 3Q by 2 pi. What is Z here? 2 square. Okay. Now just find out delta sigma P and delta sigma Q. Taking this into picture, 3Q by 2 pi 1 square, 3Q by 2 pi 2 square. So this is this will be done, and then 2 square by 1 square equal to 4. Then answer is 4:1 or 4. Answer is asked in terms of integer, you can just write 4. Thank you.